Welcome to Math with Mrs. Bibb. This week we're going to be learning about solving systems of nonlinear equations using substitution and elimination. We are still going to have the same notes from last week. That's why when you look at your table of contents, there's actually not notes in the table of contents. So you're going to use that same page from last week right at this very moment. I don't remember the page number, but you're going to use that same page from last week for your notes. And then, of course, we have a new warm-up page and practice page. So let's move on to the next slide. First, I'm going to solve using substitution. When you solve using substitution, you want to get a variable alone and then substitute it into the other equation in order to solve. So I am going to point out that 6, 7, and 8 all have a variable alone. 6 has y alone, so I'm going to use x plus 4. 7 has y alone, so I'm going to use negative x plus 4. And then 8 has y alone, so I'm going to use negative 4x squared minus 16x. Next thing I want to point out, when you do these problems, you are going to possibly get I for an answer. Remember, when you're solving by graphing, you're looking for where the two would intersect. If you happen to get I in your answer, that means that each of those graphs, they would not intersect. So the answer would be no solution. You would not have an imaginary solution. The answer really would be no solution. My advice, try the problem and then go to Desmos and check it to see if you got it right. So let's try number 6. I am going to substitute x plus 4 in for y. We have been practicing in class solving quadratics. So I'm going to look at this problem, and since I see that I do have a b value, then I know I'm going to expand this, make it equal 0, and try to factor. So I'm going to write x plus 4, and I'm going to expand x plus 2 times x plus 2. That is x squared plus 2x plus 2x plus 4, and then I still have this plus 1 out here. Then I'm going to combine like terms on the right hand side. X squared plus 4x plus 5. Then I'm going to subtract x from both sides and subtract 4. So I'm going to have 0 equals x squared plus 3x plus 1. Honestly, when I look at this, I believe that I would do the discriminant to decide if I'm going to have real roots. So let's do the discriminant. Remember, the discriminant is b squared minus 4ac. So I'm going to name a, b, and c. I'm going to do the discriminant, b squared minus 4ac. That's 3 squared minus 4 times 1 times 1. So 9 minus 4 is 5. So I am going to have real roots, not complex, because this discriminant value is greater than 0. It's not a perfect square, so I'm going to have 2 irrational roots, and that means I'll have a radical in my answer. Since I'm halfway there with the quadratic formula, I'm going to go ahead and put x equals negative b plus or minus the square root of, I already have b squared minus 4ac, all over 2 times a. Then do that multiplication, so my solutions are negative 3 plus or minus the square root of 5 over 2. Now I actually do need decimal approximations since I'm looking for where the graphs intersect. So I'm going to grab a calculator, and I'm going to do -3 plus the square root of 5 divided by 2, and I'm going to do -3 minus the square root of 5 divided by 2. I'm going to type it in my calculator. -3 plus the square root of 5. I'm going to go ahead and press equals with my calculator, and then divide by 2. And I got -0.38. Now, I hate to round and then substitute. You all know I hate to do that. But in this circumstance, I think it's easier to just round and substitute. So I got -0.38 for my first x coordinate. And let's do -3 minus 5, minus square root of 5. And then I'm going to divide by 2. So that's -2.62. Now, how do I find my y coordinate? I find my y coordinate by substituting these two values in. So I'm going to go right here. My y coordinate is going to be x plus 4. Let me do the top one first. So y is going to be -0.38 plus 4. So y is going to equal, is that 3.62? Yes, 3.62. And then I'm going to substitute -2.62 in for x. I'm going to add 4 to that. So y would equal, is that 2.38? Oh, 1.38. See, so glad I typed it in. 1.38. Oh, well, I didn't put my answer for this is 3.62 and 1.38. I'm going to pause the video and go check my answers in Desmos. I suggest you do so as well. And that was correct. So that is the correct answer, and that's how you solve that system using substitution. Now I'm going to substitute this in for y. I'm going to have x squared plus -x plus 4 squared equals 16. I'm going to expand this -x plus 4. X squared, multiply these two, that's plus x squared minus 4x minus 4x plus 16 equals 16, because that's what's on the other side. I'm going to combine like terms, so 2x squared minus 8x. I'm going to subtract this 16 to the other side, so that means those cancel out, so it equals 0. I'm going to factor this one. Because I have a common factor, I'm going to go ahead and put 2x on the outside, divide each of these by 2x, and I'll have x minus 4 on the inside. Then I'm going to do the 0 product property. 2x equals 0, x minus 4 equals 0, divide by 2, x is 0, x, add 4 to both sides, x equals positive 4. So my two solutions for number 7, oh, oops, don't do that. My two x solutions are 0 and 4. I need to find my y solutions, because remember, my answer to the solution of a system is ordered pairs. So I'm going to substitute 0 into this equation. Y equals 0 plus 4, so you get 4 for this one. I'm going to substitute 0 into the other one. Y equals a -4 plus 4, so I get 0 for that one. So if you want to pause and check to see if you're correct, then please do. I want to tell you that I knew before I graphed that this would give me a linear for number 6, and this would give me a parabola for number 7. Now, although you don't know yet, but I just want to point out, this is actually a circle. And if you graph it, and you can type it in just like this in Desmos, you'll see a circle, and then this is a line. So you're looking for the point or points where this circle and this line intersect. Now, number 8, I can look at that and tell you that this is a parabola because I don't have y squared, and so is this one. So I'm looking for the point or points of intersection if there are any of these two parabolas. So let's get to it. I'm going to use substitution. I'm going to substitute negative 4x squared minus 16x in for y. So keep the left side the same. And then substitute negative 4x squared minus 16x minus 10x. So I said that all together like that was the same. I substituted this expression in for y. That's where this came from. And then I brought this down to join it. Okay, so then I'm going to make it equal 0. I'm going to add 4x squared. And this is negative 26x. So I'm going to add 26x to the other side. So 6x squared plus 36x plus 48 equals 0. And I will tell you what I'm going to do first is the common factor here is just 6, so I'm going to divide away the common factor. Since I'm solving, I can divide away the common factor. So x squared plus 6x plus 8 equals 0. Then can I factor? Can I find factors of a times c, factors of 8 that will give me a sum of 6? 2 times 4, so yes. X plus 2, x plus 4 equals 0. Do the zero product property, set each factor equal to 0. X will equal negative 2 on this one, and x will equal negative 4 on this one. So negative 2 and negative 4. Those are my x coordinates, negative 2 and negative 4. Now let's substitute for the y coordinates. I'm going to substitute negative 2 into this expression, negative 4x squared minus 16x. Y equals negative 4 times negative 2 squared minus 16 times negative 2. Y is going to equal negative 4 times 4 plus 32. Y will equal negative 16 plus 32, which is 16. Substitute negative 4 in. Y equals negative 4 times negative 4 squared minus 16 times negative 4. I'm so sorry, that's all scrunched together. Y equals negative 4 times 16 plus 64. Y equals negative 64 plus 64, which is 0. And please do go type it in to check to see if I'm right. I'm pretty sure I'm correct. Let me know if I'm not, but I'm pretty sure I did it carefully enough that I know those 2 points are the points of intersection. Now, moving right along to elimination. I'm going to solve these using elimination. If I were you, I would get your constants on one side and your variables on the other side, except for number 10. We'll talk about number 10 in just a minute. Excuse me. So I'm going to rewrite number 9. I'm going to move this 11 and move this y. So I have x squared minus 7x minus y equals negative 12. And then I have negative x plus y equals negative 4. Now, I'm going to eliminate y. I really don't have a choice here because I have 2 x's I have to eliminate y. Well, it's set up really nicely. I can go ahead and add these two together. X squared minus 8x, that goes away, equals negative 16. Then I'm going to move the 16 to the left. If you want to try to solve by completing the square, that's perfectly fine. But I'm going to move the 16 to the left and do the discriminant to see what my roots are going to look like. Will that factor? Oh, it will factor, so I know. Never mind. I'll go ahead and name A, B, and C. Since it will factor, A times C, sum of B, -4 times -4, then I know I'm going to have two real rational solutions. So x minus 4 times x minus 4. Actually, I may only have one, and we'll see why in just a minute. So x minus 4 equals 0, 0 product property. So no matter which way you go, x is going to equal 4. You don't have to do it twice. So that means that they only touch each other. They don't intersect 2 times. And then I'm going to substitute my 4 into that bottom equation. X is 4, but it's -4 because of that negative there. I'm going to add 4. So y will equal 0. Again, you can type both of those in Desmos to see if they intersect at 4, 0. Now, looking at the next one, y is already alone on the left side, so I'm going to eliminate y. I'm going to multiply the top by +1, the bottom by -1, or you could just subtract. But I like to be consistent, so you can ignore what I just said and do what I'm about to do. Y is going to equal 9x squared plus 6x plus 2. Negative y is going to equal -x squared plus 8x plus 19. Add them together. 0 is going to equal 8x squared plus 14x plus 21. I don't have a common factor, so I'm going to name A, B, and C. I'm going to do the discriminant, b squared minus 4ac. 14 squared minus 4 times 8 times 21. So 196 minus 32 times 21 is 672. 196 minus 672 is -476. I can stop there. This tells me I'm going to have two complex solutions, which means those two parabolas do not intersect. The answer is no solution. There's no point of intersection for those two parabolas. And if you don't think it's true, go type them in Desmos to see how it works out. Okay, so let's look at the next one. I am going to get x and y squared on the same side together. I think I'm going to add x squared and subtract y just to keep it positive. Subtract 29 here. Going to subtract 2x squared, which then I defeat keeping it positive, but it's okay. I'm going to subtract 2x squared. So on the top I have x squared minus 5x minus y equals -29. On the bottom I have -x squared plus y equals -1. I am already set up to add these two together. X squared and -x squared cancels out. Nothing to add with -5x, so I put -5x. -y and y cancel out, and so I have -5x equals -30. And it's so nice to get that kind of equations because we all know how to solve this. Divide by -5, x equals 6. So I only have one point of intersection. 6 is the x coordinate. To find the y coordinate, I think I'll just use the bottom one. So x squared plus y equals 2x squared minus 1. I'll substitute 6 in. (36) plus y equals 2 times 36 minus 1. 36 plus y equals 72 minus 1. 36 plus y equals 71. Subtract 36. Is that 25? 35. I was going to say 35. Shame on me. Y equals 35. So 635. And I am going to go type that in and make sure it's correct. You should do the same. And that's all the notes for this week. I know it's a little longer than last week, but now you know how to solve by graphing, by substitution, and by elimination. I hope you have a wonderful day.